Good morning. Welcome to today's webinar sponsored by Frontier Precision. This is Steve Richter with Frontier Precision, and I'm going to do a brief introduction and hand it over to Jay Haskamp in just a moment. But again, welcome to our introductory webinar on the Pix4D software and integrating UAS deliverables into your current workflows. A couple of housekeeping things. We are recording today's session, so we'll have it available for playback here later on this week and available on our blog. And then also, we're going to save questions until the end. This is a bit of a technical topic, so we don't want to interject in the middle of the flow of the presentation that Jay is going to have here. So we ask that you just put your questions in the chat window, and we'll do our best here at the end of the webinar to get to those. And again, make those available to those who have asked the questions. So again, thank you for coming and attending today's session. We hope you enjoy it. And with that, I'll hand it over to Jay Haskamp. Here you go, Jay.
All right. Thank you, Steve. Again, I just want to reiterate with Steve and just welcome everybody for showing up today. Appreciate everybody being here, and hopefully you'll find this this informative. So today, as Steve said, we're going to just kind of give a quick overview of Pix4D software, as well as a few other things related to it, kind of some little side things with Pix4D, and then just some things to UAS in general. I just want to put out there, I don't know how well known it is, but we are a Pix4D distributor. So any of you that are currently using or looking to using, we have plenty of knowledge and ability to help you guys out with anything Pix4D. Let's see here. So just a quick introduction. As Steve said, my name is Jay Haskamp with Frontier Precision here, and I'm kind of one of our guys responsible for technical support, training, services, and things like that for Minnesota and North Dakota primarily. However, I do help out in other areas of our territory, which you can see on the screen. I am a FAA licensed UAS pilot and one of our Pix4D people here at Frontier. And I'm working out of our St. Cloud, Minnesota office, which is this little yellow dot right here for those of you that may not know where that is. So our agenda today is kind of going to be as follows. We're going to first do a brief overview of just photogrammetry concepts in general with UAS, as well as some recommendations on how to get the maybe the best data that you can out of these systems, just some things to be aware of and to look for. We're going to do a quick overview of the Pix4D Capture mobile application, which can be used with some more, I guess, commercial style UAVs like DJI products and things like that. We'll do a quick overview of the Pix4D desktop software, and in there we'll go through several things such as importing data from our UAV, working with manual tie points and ground control points, and then we'll move into processing and creating deliverables out of Pix4D. And then lastly, I want to do just a little quick rundown of the Pix4D cloud service, which is also a nice utility that you can use. And again, as Steve said, we'll probably hold off on the questions until the end and try to answer them at the end of the session. And if we run out of time at the end and we don't get to all the questions, I believe we will be able to just kind of document them and get in touch with you one-on-one afterwards. All right, so first let's just start with talking about photogrammetry from UAS. As we all know, UAS has become a very hot topic and a very common tool as of late here, and just with a lot of very rapid advances in the technology, it's now becoming a very cost-effective way to collect aerial images and other types of aerial information. To break it down as easy as we can, UAS utilizes 2D images taken from some sort of UAV platform, and then with some sort of software such as Pix4D, we're able to produce rather precise orthomosaics, digital elevation models, point clouds, and a few other deliverables. And it's being used in a lot of industries that we're finding out, such as maybe construction, surveying, engineering, agriculture, inspection, even things like emergency response and forensics and real estate, and things like that. So before we start, maybe we should take a quick step back and just talk about, first maybe answer the question, what is photogrammetry? So I'm sure a lot of you know what we're dealing with here, but simply put, photogrammetry is basically just taking measurements from images. So from a US perspective, we're going to fly a site and maybe a specified grid or a pattern and take a series of images. And then from these images, we're able to put them into software and extract out information to make 3D models and point clouds and orthomosaics. And this is accomplished by something that we call stereoscopic parallax. And just to try to put it as simple as I can, stereoscopic parallax is basically caused by taking photographs of the same object, but maybe from different perspectives or positions. So if we take a picture of an object from two different perspectives, like we can see on the screen here, we can start to pinpoint its size and its location. However, if we do so with two images, we might have some rather large error, as you would see here in red. However, if we take the same scenario and maybe add in a third image at a sharper, different angle, or even multiple images, we can start to reduce our error of that location and that size, as we see here in green. So the cool thing about Pix4D is this is basically all done automatically for us. Before softwares like Pix4D, we had to use kind of these traditional methods, which meant using a stereo plotter. These machines were large, and they used a series of scopes and wheels and pedals, and honestly, they required some very skilled people to run them. So some of this UAS software has really made things a lot easier for people recently. So if we look at how Pix4D accomplishes this, we use something called multi-ray photogrammetry, and basically through some automated workflows, we can extract out what we call automatic tie points. And basically the reason we can do that with a lot of images is we can leverage redundancy, maybe from high overlap of several images in our flight missions, and also we can utilize the more powerful modern computing capabilities that we have today. So if we look at kind of how we do this, Pix4D is first going to analyze the individual images and extract out what we call key points. Key points are kind of what we're seeing here on the right-hand side, the little orange plus symbols on the image. And these are basically extracted out from unique texture or objects in the image. So any pixels or information that it thinks is unique, it'll basically create a key point on that. Then once all of our key points are extracted, Pix4D will go through and basically match them together from image to image to create what we call automatic tie points. Now, automatic tie points are basically the key points that Pix4D has successfully matched between overlapping images. All right, so to keep kind of moving forward, we're going to shift gears a little bit and just go through some terminology. I feel it's important to know what some of these acronyms and these terms are to better understand the software. The first one is GSD, which stands for ground sample distance, or you might hear people say ground sampling distance. Basically, GSD is the resolution of the image content, or in other words, it'd basically be the distance of the pixel on the ground. So whatever your ground sample distance is the size that your image pixel is representing on the actual ground. So this can be affected by several things, such as the resolution of the camera sensor, the focal length of the lens, and the UAV's altitude, or the height that it's flying above the ground. So as a quick comparison here in ground sample distance, we can look kind of at these two images on the screen here, and we can see the image on the left has a ground sample distance of 2.5 centimeters, and the image on the right has a ground sample distance of 10 centimeters. So you can see there's a rather large difference between the two images in terms of their resolution. So obviously we know that the image on the left, when we run it through and process it in our software, is going to produce far better than maybe what we see on the right-hand side. Some additional terminology. First one would be GCP, which is what we call a ground control point. A GCP is basically a known point or location that we use to position, scale, and orient a project. So typically this is going to be in the form of some sort of target on the ground that we're going to measure in with surveying equipment such as GPS or a total station. The next one is MTP, which is a manual type point. So this would be some sort of landmark or feature that we use to refine our camera alignments or to kind of anchor objects in our ray cloud. So this is going to be a necessary practice for maybe some more difficult sites that have maybe a homogeneous type texture and they don't produce very many or don't produce enough automatic tie points. We might have to go through and manually tie things together. The next term is nadir, and nadir is basically just a flight where the camera on the UAV is pointing straight down to the ground. There's no camera at an angle or anything like that. It's just strictly pointing straight down from the UAV, and that's typically the preferred method that we like to use for projects where maybe we only need, you know, a 2D deliverable. Maybe we only really care about a nice orthomosaic image, something like that. And then the next one is oblique, and oblique is kind of the opposite of nadir, where oblique is a flight where we have our camera oriented at an angle to provide depth to the objects in the images. So if we're looking to do a project where we want some 3D deliverables, maybe we have some buildings or something like that where we want more of a 3D, whether it's a 3D model or a 3D point cloud, we may utilize an oblique flight to get some more of that depth of our objects. A couple more here related to accuracy. So our first term is relative accuracy. So this is basically the difference or error between two objects within the project itself. So in other words, how accurate or how well do the objects in our project fit with each other within the actual project. The next one is absolute accuracy, so this kind of takes it one step further. It's going to be the difference between the error and, or the difference or error, excuse me, between the coordinate location or the location of an object in the project and where it actually lies on the ground. So how accurately the project and its objects are placed in the real world per survey control or whatever we said is going to be our absolute accuracy. All right, so we kind of got our terminology out of the way. Let's maybe now go through some best practices when you're capturing your data. So this best practices are kind of important to utilize the full power and potential of Pix4D to get the best deliverables. The first thing we want to be aware of, first and foremost, is just image quality. So in terms of image quality, some things that we want to avoid would be blurry images or over or underexposed images. We want to make sure that we know our camera settings for things like shutter speed, aperture, the ISO value. Also, we want to know how these settings affect our images. My opinion is it's good practice to maybe, before you do your flight, take some sample images with your camera and check them before you do the flight, just to make sure that the lighting and everything is set up properly and it's looking good. Nothing more frustrating than when you do an entire flight and come back and maybe find out that all of your images are overexposed and you got to refly. Also, things to be aware of would be the speed of the capture and the wind that you're flying in. So a couple things depending upon your UAV platform. Is it set up to fly continuously and take pictures as it's moving, or are we kind of utilizing a stop and go technique where each image location UAV is going to stop and stabilize and take a picture and move on? Also, things like, are you flying downwind or are you flying crosswind? Depending upon the type of UAV you're using or the manufacturer, one way or the other may be recommended. So just kind of be aware of your surroundings in terms of wind and flight speed. Also, another thing that can be problematic would be the image capture rate. Don't set your project up to capture images at a faster rate than the camera can take them. If this happens, the camera will be triggered to take the next picture while it's still or save the previous image to the camera's memory. It's a fairly common mistake and can be basically prevented by just checking your flight speed, your percentage of overlap. Some manufacturers even give you some indication as to the kind of the trigger and the store speed and if it's going to work or not. So just again, be aware of that. Other issues that we could have may be due to terrain in our project. So if we have very homogeneous areas, like you can kind of see in the image here, that will more than likely provide little to no automatic tie points or key points to fit together, and this will cause the software to struggle when trying to fit your images together. It's going to force us to go in and look at these exhilarating, fantastic images of nothing and try to add manual tie points to try to fit this stuff together. Also, moving objects such as trees and water, whether there's leaves or no leaves, trees can be difficult and provide some hurdles for us. Ideally, we want to see what we call good terrain. So terrain that's going to provide adequate results for us are going to have good surface texture, lots of different features and structures and lots of things going on to extract our key points from. All right, so going back to ground sample distance, this is kind of one of the main things we look at, or main things that we use as a idea to kind of drive our project. So I want to just dive into ground sample distance a little bit more to kind of make sure that we all understand it. As we said earlier, ground sample distance is mainly affected by three things. So obviously we have the distance from the camera to the object, or how high our UAV is flying above our project. We have the focal length of the camera's lens, and we have the resolution of the camera sensor. So we'll just look at each one of these a little bit closer here. If we first look at the altitude, just to kind of give a kind of an obvious comparison, we can see that the image on the right was flown or captured much closer to the ground than, say, the image on the left. So that means we have a lot more detail. Our pixel size is much smaller on the ground due to our altitude. So because of that, we have more resolution. We're able to extract more information out of these images. Also, if we look at the comparing two different focal lengths, here's just kind of an example with what we would see maybe with a longer focal length. So we would get a little bit of a closer view of the image in more detail on the right with a 35mm lens versus on the left with a 24mm. But you can see we also have a smaller footprint or a smaller field of view. So these are kind of one of those things you have to just know how this stuff works and be aware of it, because although we get more definition and more resolution, we have to take several more pictures to cover the same patch of ground with a better lens. So again, it can be problematic for a couple of reasons. One would be image size and just the amount of images that we have to deal with, and if our computer can process them, but also flying at low altitudes, going back to the speed of capture, a camera has to trigger a lot faster because we have to take a lot more pictures. So again, just kind of be aware of how these all can affect your project. And then the next one is the sensor resolution. So this slide is basically a comparison of camera resolution. So there isn't a lot to explain here really, other than having a higher resolution camera, as you can see, will obviously produce a higher resolution image. So one thing to keep in mind is, again, the higher resolution your camera, the larger the image file sizes are going to be. So it's the more data you're going to have to, your computer's going to have to process, the more storage you're going to need, things like that. So this stuff is all kind of relative, and you just need to know what it does and kind of figure out where your sweet spot is and what works for you. Pix4D does offer a pretty nice ground sample distance calculator. It's an Excel spreadsheet you can download off, I believe, off their support site. Basically, it'll give you a good idea of what you're working with. So you can input different parameters such as the sensor width, the focal length of the lens, the height of the flight that you're going to fly, and then basically the size of the image that the camera captures in pixels. And then once we put all this information in, we can see here that our ground sample distance is going to be about 1.8 centimeters per pixel. And that'll even calculate the width and the height of the image footprint on the ground. So you can see each image is going to be 85 meters by 64 meters. So it's just kind of a helpful little tool to input your information in there and just kind of see what you're working with. A lot of the softwares depends on the software. Some of the apps do, but a lot of when you get into the more commercial type systems like the micro drone systems or the Trimble systems, they're going to basically compute that, and they're going to tell you what that information is during your setup. But if there's ever a question you want to know, this spreadsheet's pretty helpful. Okay, so if we kind of wrap all that in, we kind of want to talk now a little bit about proper camera selection. So obviously, those of you who are doing some of this, you know that there are many different types of cameras and sensors out there, and there's a lot of differences between sensors and lenses and things like that. It can be kind of daunting to go through all the information at times. There's also sensors that collect different type of information. So we may have our standard RGB cameras, but we also will deal with thermal cameras, multispectral cameras, near-infrared cameras, LiDAR, things like that. So the world of UAS isn't strictly stuck with just your standard cameras. There's a lot of different types of sensors that we can also work with. Just remember that the higher the resolution of your camera, the larger the file sizes are going to be with your images. So that can come into play when you're working or you're looking at things like the accuracy of your project versus just your computer's ability to work with the data. Can your computer adequately process these images with these large file sizes? Maybe you don't need to be so high resolution for what you're doing. Maybe you can water it down a little bit just to get through the data. Pix4D also has some options in there to process at a lower resolution just to kind of speed things up a little bit. It'll do a less high point extraction. It'll produce a lower resolution orthomosaic and things like that. So there are some things we can use in the software to kind of work around that a little bit. But more importantly, it's just to know how all this will have effect on you and knowing what you will need to get the job done. So just again, making sure that you have the right camera from the job. And remember also that, cameras from a consumer perspective are always kind of marketed and sold about how many megapixels that they have. Just remember that it's not just about the megapixels. There's a lot of other things that come into play. The type of sensor is extremely important. And in the interest of time, I won't dive any deeper into this. I do want to show you, however, that we did, if you haven't seen it, we put out a pretty helpful blog post that we titled Making the Sense of Imaging Technology. So I'm going to try to find it here. Here we go. So if you guys are interested in this, just let us know. But this talks about, CCD versus CMOS sensors, looking at the different types of sensors in the cameras, kind of comparing it as to what you get on an image, talking about exposures and ISOs and image sensitivity, and then also looking at some of the more popular UAV platforms and just kind of laying out their sensor sizes and just kind of giving a little bit of an overview on how important picking the right image sensor is. So this is on both of our mapping and our surveying blogs. So it's either fpimapping.com, I believe, or fpisurvey.com. But if you have trouble finding it, just let us know. But I welcome you to go ahead and read through that. There's a lot of good information in there. A couple other things we got to deal with. Again, dealing with lenses. Fisheye lens versus a perspective lens. So there are some cameras out there on UAVs, such as maybe a GoPro camera or something like that, that have these fisheye type lenses. So if we kind of compare these, side by side, we can kind of look at the same area where we see a fisheye lens on the left, and then we see what we call a perspective lens on the right. Fisheye lens, you know, since things are maybe a little bit distorted, they can maybe make our project not as good as we want it to be. So Pix4D has some cool stuff in their camera setups where we can actually run an algorithm to do a fisheye lens correction in the camera parameters. I don't list it here, but there's also a, you know, we talk about a rolling shutter versus a global shutter. A global shutter is obviously better on a moving platform, so there's also some corrections we can do for a linear rolling shutter as well in Pix4D. Image overlap. So this will have a significant effect on our data. So as you can see, kind of our comparison here, having an overlap of around 75% will likely produce over 1,000 automatic tie points and give us nice consistent results. However, if we do something more minimum, maybe like a 20% overlap, we're going to get a much smaller amount of automatic tie points to tie our images together. And because of these mismatches, we might see a little drift or inaccuracy in our data, as you can kind of see on the lower right, where the images are kind of drifting up. So a lot of questions we get asked are in regards to what would be recommended overlaps to use for different types of flights that Pix4D will be able to run through and process good for us. So these are kind of what Pix4D recommends. So if we're looking at a typical nadir flight, we're going to recommend something like a 75% front overlap and then a 60% side overlap. So when we're flying, you know, a nice back and forth type grid pattern like we see on the screen, we'll get plenty of overlap and redundancy of our images for Pix4D to extract the automatic tie points out for us. Corridor mapping is another very popular concept that people like to ask lots of questions about. So for some sort of linear corridor project, we'd recommend an 85% front overlap and about a 60% side overlap. And ideally, you'd want to fly a corridor in 2 passes, maybe down and back, just to make sure we've got adequate coverage. One thing to keep in mind with corridor mapping is you're also going to need several ground control points throughout the project, not just one at the beginning and one at the end. Because we only have 1 or 2 passes, we need a lot more ground control to tie the data down and make sure it's right. If we look at an oblique flight, this would be maybe for a 3D model type flight. Here we're going to recommend about an 85% front overlap and a 70% side overlap. We also want to pitch the camera at a slight angle, so maybe like a 70-degree angle, something like that, with these overlap settings in the camera pitched, also coupled with flying maybe a double grid pattern like we see on the screen here, we'll get sufficient coverage for getting more depth on our vertical surfaces and get a better 3D model from our data. Just to kind of give you an idea here, it's basically the same data processed with a nadir flight versus a double grid oblique flight. So on the left we can see the nadir, on the right we can see the oblique, and you can definitely see there's a difference between the two. We get much more definition and detail with the oblique flight on the right than we would do, or we would get with the nadir flight on the left. All right, so also just kind of be wary of some low resolution sensors and some issues we might see with those. Low resolution sensors would typically produce less key points in Pix4D, first and foremost. Because of that, this will result in less matches or automatic tie points between the images, and will certainly have an effect on your project's accuracy. Also, if you have a lower resolution sensor on your UAV, it's highly recommended that you try to account for it by using a lot more overlap in your images. That's going to be key to process these things successfully in Pix4D. However, we would recommend just trying to use a higher resolution sensor for your project, just to ensure that you get sufficient imagery. Also, a couple other things, dealing with larger projects where you have to fly one area with multiple flights. Just make sure that between the 2 flights that you set them up so they overlap properly. Okay, so especially if we're going to process them together in Pix4D, maybe we're going to bring in 3-4 flights and process them in one project. We just want to ensure that we have enough overlap so that they'll tie together properly when we process them. It's also maybe not a bad idea to have manual tie points or some ground control points, in the area that you kind of see boxed in red here, just to make sure we can take any question out of there if we have to in terms of tying our 2 flights together. Ground control points are very important. I'm pretty strongly opinionated on ground control points and their use in your projects. So they should be some sort of target that you can visibly see in the images. A couple things, we want to make sure that they're large enough to see at higher altitudes. Based off of just some of the stuff I've been doing, I would recommend a black and white kind of a hatch pattern like we see here on the slide. Another thing to consider too, which I've also had issues with, is just knowing the type of material that your targets are made from. Try to avoid materials or finishes that maybe will get some glare, kind of wash out from the sunlight. That can happen. And then you can see here, this is just an example of the ground control targets in the project that we're going to look at today. So you can see they're nice and large and they're easily identifiable from the images. All right, so a few more things to wrap up ground control points. I'm spending a lot of time on these, but they are important. So just a few tips about setting ground control for your site. Those of you that have a surveying background, the rules, as we would say, for ground control points are very similar to what we would use for maybe like a site calibration with GPS equipment. So first, you don't want to use any fewer than 3 ground control points per flight. This would be a minimum. Definitely would recommend using more. Typically, you want to look for, say, 5 to 8 per project as a good baseline. But again, having more is not going to hurt you, and I'll tell you why in a minute. But we want to make sure that they're evenly distributed throughout the site, kind of just as the little animated thing shows on the right there. We don't want to cluster them all in one spot on our project. We want to spread them out and try to get some out towards the edges of our project. We'll also want to make sure that there's some in the middle, especially on sites where maybe we have a lot of vertical relief. We want to have some maybe on some of the high points and some of the low points, just so we have more references to kind of tie things together. Definitely do not lay them out in a straight line. That's going to give you problems. And if you have extra ground control points available, you can definitely then use some as checkpoints, which is nice to be able to verify that your data looks good. Okay, so some common errors that are made with ground control points. This is maybe more related to Pix4D specifically. I'm not sure. I know a few other softwares kind of input data the same way, but first and foremost, make sure you know what coordinate systems you're working with. So when you're setting up your Pix4D project, you'll need to specify the coordinate system for the images that you're inputting, the ground control point file, and then also what coordinate system you want your deliverables to be output into. So make sure you know what these 3 coordinate systems are, what they relate to, and make sure that that you select them or you set them up properly. Also, verify the format that you're bringing your ground control point file into your project. So make sure you're using things like the proper unit settings, whether it's feet or meters, coordinate order. So if it's northing easting elevation or easting northing elevation, or as an example, Pix4D looks for XYZ or YXZ. So know how that relates to northing and easting if you're working in that format. So those are all things just to be aware of. So when we process a project in Pix4D, and we can look at this more in depth in a minute here, but we're going to get something called a quality report. So this is what we're going to get when we're done processing a step in Pix4D. And this top part is pretty important in our quality report. So the first thing we're going to probably notice is just the image that we see at the bottom of the screen here with all the little dots and lines in it. So what is this? Well, It's basically a visual representation that Pix4D is going to give us on how well the images in our project tie together. So at first glance in the image, we see that all these little dots are all one color. They're all green, which tells us that they're a single block of images. And then we also see that, you know, maybe not as much around the edge of the image, but towards the middle of our project, the lines are nice and dark. And the darker the lines, that's a good thing. So this means that we have a single block of images, and the darker that the lines are, it means the more matches that we have between each image. So next thing you want to look at is kind of to the right up on the top, is to make sure that every one of these items has a little green circle with a check mark in it. This means that everything is looking good so far. If we have a scenario where we don't have any green check marks in here, maybe have a little warning symbol in the quality report, or something just doesn't look right or anything like that, we want to basically stop and fix any of these issues first before we move on and do any additional processing. So basically what this is telling us in this particular one is the average or the median is about 35,000 key points per image. And out of the 127 images in the data set, it was able to tie 127 of them together, so 100%. The camera optimization we see is 0.44%. So basically what that is based on the camera's model, it has a predetermined set of values for what the sensor size and the focal length and stuff like that is. After we run through and we process the data, basically it's doing like a camera calibration, and this comparison is what the manufacturer camera specs say and what Pix4D calculates, and we want that to be as close as possible. So we're within 0.5%, which is really good. The matching, this basically is just saying that there is a median or a middle of about 13,800 matches per image. So that'd be your automatic tie points, for example. And then down at the bottom here, you can see this project used 7 ground control points, all in 3D, and the mean error of all 7 points was about 4.5 centimeters. So everything looks pretty good here. If we're happy with it, we could then move on and process our deliverables. This is basically what we'll see after our initial key point and automatic tie point extraction and trying to fit everything together. Now this would maybe be a not so good scenario. First, notice on the bottom the weak matches and even the lack of matches in the image at the bottom of the slide there. So also notice that we have dots down there. Those represent our image locations. Those are several different colors, indicating that we don't even have a single block of images. We actually have 7 blocks. You can see it's highlighted up above in yellow in the text. And then also there's 3 items in our list that kind of have a warning symbol. So at this point, we would not want to process deliverables from this data set. We would want to try to go back and fix our issues first. The question would maybe be, how do we do this? Well, we would probably need to go in and add several manual tie points first to tie everything together. And then we can also see on the last item there that we're lacking ground control points. So we probably want to add in some ground control points. And then after we bring more information in, we can kind of we call it re-optimize. But we can go back through and try to refit all these images together with additional information. Okay, so that's kind of our background. Hopefully that didn't get a little long-winded there, but I just feel before you can really grasp or understand the Pix4D software, it's important to really have all that stuff down. Before we jump into there, though, I do want to quickly talk about Pix4D Capture. There's a lot of people using like DJI solutions and things like that. Pix4D does have a mobile application called Pix4D Capture. It's for both Android and iOS, and basically it offers users to do a pre-programmed flight with their UAVs, as well as also do some free flying. So you can kind of see the different types of missions on the bottom, whether it's grid, a polygon, double grid, circular, free flight. Hopefully this hasn't changed since I put the slide together. These things are always changing, but as of the time I made this is kind of the list of what's available or what's supported on the app. So mostly DJI products, but you can also see something like the Parrot or the 3DR solutions are available as well. and you can see whether it's available on Android or iOS or both next to the little image there. So just to give you a quick rundown of what it looks like, this would be the home screen on the iOS. First, we have a login, so this would be whatever our Pix4D login is. If you don't have one, you can create one. If you've purchased the Pix4D software, this would be your login that you got when you purchased it. Next, you have a settings menu. We'll go through that shortly. And then down below here, you would see, okay, you want to plan a mission. Well, let's pick what type of mission that we want to plan. So basically, pick that and you'll proceed to the mission setup, which we'll look at in a minute here. This is the home screen for the Android version, which is very similar. It's just laid out a little bit differently. Again, you have your login, your settings, and then your missions. You can notice that the Android, hopefully this hasn't changed yet. Well, I guess it'd be good if it did, but from when I put this together, the Android version didn't have the polygon flight. So that was only available on iOS when I put this together, but I would assume that's going to change very soon if it hasn't already. So this would be when you go into the settings screen. So this is kind of your setup here. First you see, you pick what type of UAV that you're using, the units of your project, whether it's feet or meters. Number 3 here is if we wanted to automatically sync our data when the mission ends. So what that means is all the images are being stored on, let's say if we're using a Phantom 4 Pro like above, all the images are stored on the SD card on the Phantom. And when it's done, if this is checked, it'll automatically start pushing the images to our mobile device. If we want audio feedback during the flight, we can turn that on or off. The next one is if we want to save the offline map when we maybe don't have internet access to our maps in the field. We can just set the provider for our street maps and our satellite maps, and then if we want to see some of these advanced settings or not, we can turn that off or on. We go through, we set up our units, and then we get into our kind of our mission manager. So this is what our mission manager screen looks like on our mobile device. I believe this is the iOS version. First, we have our little button here to go back to the home screen if we need to make any changes. Next, there's the flight settings button. So there's a project settings or an app settings, and then there's also like a flight settings or parameters. So we'll go into that shortly here. The next button down in the lower left is like a center on position button. So when you hit this, it'll use the GPS location of your mobile device to basically just pull the map up of where you are. And then the next one on the right side, the reset button, this will basically pull up a new mission block in the area where we are on our screen. This one, I forget, I believe it's just if we're zoomed in or zoomed out, it's just kind of a fit to screen button. And the next one is basically to toggle between the satellite map and the street map on the screen. On the left here is where we set our altitude or how high we want to fly. It's just kind of a slider bar up or down. It shows you how many feet or meters. And then on the bottom, that'll kind of give us the approximate size of our mission and an approximation of the time it'll take to complete the mission. And then on the right-hand side, it'll basically, once we're connected to our UAV, it'll show us, you know, the battery life, how many satellites we're tracking. It'll give us our altitude, how far away it is, the speed it's flying. It'll kind of give us just our statistics as we're flying and moving. And then up on the top, the little camera button, that allows us to toggle between either the map view that we see here or the live video feed from the camera. So we can kind of switch back and forth between the two while the flight's going on. If we hit settings and we go into the flight settings screen, this is what we're going to look at. So at the top, we can see if we have the ability to either display the normal or the advanced settings. And as we go down the list, this is where we can adjust our camera angle. So this could be, you know, if we're doing a nadir flight or if we're switching to an oblique flight, this would change automatically, but we can manually move it. We can set our front overlap and our side overlap. The next one is if we want the camera to always look at the center of our grid of our project. So as it flies, if we want it to kind of rotate and always point at the center, we can set that yes or no. Trigger mode, so we have fast or safe mode. So fast is it's just going to take images on the fly as it's moving. Safe mode, it's going to stop and take pictures. We can set our drone speed between fast or slow. White balance if we want auto, sunny, or cloudy. And then whether or not we wanted to basically ignore our home point or our GPS location when we take off in the checklist. So it's a pretty basic, pretty easy app that you can use to get some of these flights done with some of these more consumer type drones. However, if you're not using Pix4D Capture, you might ask, can I still process images in Pix4D? Definitely you can. There are many other applications, methods out there for collecting data. Don't worry about it. Pix4D generally will read the location and the IMU information from the drone right out of the EXIF data from the images and then place them in the project. So some manufacturers will write the image, or I should say the IMU and the locations up right to the image EXIF information. So that's what Pix4D is looking for. However, if you don't have that, and you maybe have like what we call a database file or a flight file, you can also load those into Pix4D, whether it's like a CSV file or a text file. And Pix4D works just fine with your higher end, more commercial type systems. All right, so got that out of the way. A lot of stuff there. Again, if there's any questions, definitely throw them in the chat box or contact us. But I want to kind of do a little dive or a tour of Pix4D now. So first thing I'm going to do is open up Pix4D here. Just to quickly show you, this is just kind of our start screen. Basically, we have our create a project, open a project. I'm going to go through this whole process here. Once we open a project, as I'm going to do here, you'll see two views. We have a map view and a ray cloud view. So the map view is basically our flight grid or our project overlaid on a satellite map, and you can see the lines that we flew, and each one of these little red dots is where an image was triggered, and then the little blue plus symbols would be our ground control points. And then the next thing down is we can throw this into a ray cloud view, where at this point we can kind of see more of a 3D view of our project. So we'd have these blue and green symbols here, and this is basically our pre and post processed camera positions, things like our ground control points. These would be the automatic tie points that the software has extracted. And then if I turn those off, and this would be a fully processed project, here we can see our point cloud that we created. So this would be our full resolution point cloud that was processed. And then if we take that one step further, we can turn on our triangle mesh. So this is basically like a 3D mesh or a surface then created from our point clouds and basically with the imagery, excuse me, the imagery and the colorization overlapped on it. So there's some pretty cool stuff here. There's also an orthomosaic. I don't have it pulled up in here. But what I want to do is I recorded several videos of processing this project. So I'm just going to play them and kind of talk through them to show you how we got to this point here. So if we go here, the first video is the initial processing. So I'm just going to hit play and kind of talk through it. We're setting up our project. We're giving it a name. We're telling it where we want to store things. I typically like to structure my project to have an image folder, a control folder, and then a project folder. We have a new project here. Now it wants to look for our images. So we can add a full directory of images. We can add individual images, or we can even add videos. If we have high-def video, we can bring a video in and have it extract images out of there. But I'm going to go to my images folder here, and I'm just going to select all of my images and hit open. And now it's going to bring them into basically my database here. And you can see there's 72 of them. I hit next, and what it's done at this point is it's pulled in all the images. And since this was done with the DJI Phantom 4 Pro, all the information was written to the EXIF data. So it's already in there. It already recognizes that the coordinate system is WGS84. We can pick from EXIF to populate our images. Also, we have our camera model. A little quick there. I'm just going to go back and pause it. We can see if we don't have EXIF data, we can pick from file right here. Hopefully you can see my mouse. From file is where we can pull it in from an outside file, like a CSV file. And then, like I said, it automatically detects your coordinate system. Typically, the coordinate systems that UAVs are going to collect in are going to be WGS84, but we can change that if we need to. And then our camera model is going to automatically be pulled in. If we hit edit here, this is where we get to our camera edit, our camera parameters, where we can edit things like the fisheye lenses and things like that. So everything looks good. We're going to hit next. This says, okay, what coordinate system do you want to output? So first thing I notice is I want to set it to feet. We can work in an arbitrary coordinate system if we need to. We can't utilize features such as the background map and stuff like that. But we can search for a system. We can look at the list, which we're doing here. The list doesn't have everything. If we have a EPSG file or a PRJ file, we can definitely import that in and use that to set our coordinate system parameters as well. On this one I just did in Minnesota State Plane, so we're going to roll with that. And we're going to go next. And now it says, okay, what do you want to do? So we have 3D maps, 3D models. So maps is more of a 2D process. 3D models is more of a 3D. And then for the interest of time, if you want to go fast, you can do a rapid or a low resolution. Also notice, back up just a second again, also notice there's templates here for multispectral cameras, thermal cameras, and things like that. So there's definitely different parameters there that we can use. Then we go into our project. So this is a screen that we've seen already. This just kind of is your first check to make sure that your coordinate system and your parameters aren't all messed up, to make sure that it comes in the right spot. Notice down at the bottom we have kind of washed out here with my text, but there's an initial processing, point cloud and mesh processing, and an orthomosaic and index processing. So this is going to be our three main steps in Pix4D. And what we're going to process. So remember, we look back at the quality report. That's what we're going to look at after our initial processing to make sure everything looks good before we move on to the other processing. Before we do that, I like to bring in my ground control points just to make sure I don't have any coordinate system issues. So it's automatically going to pick your output coordinate system, but if your ground control is in a different system, you can choose that. I'm working in northings and eastings, so I know that that's actually YXZ. So I pick that, and now I can go out and just basically browse to my control file, which is just a simple CSV file. And I bring that in, and you can see that I now have my ground control here. And now when I hit OK, what I'm looking for is, you see the little blue plus symbols on the screen. We want to make sure that those are, one, in the project, and two, maybe not shifted or off to the side, that everything looks right in terms of what we're doing. With that said, we want to uncheck steps 2 and 3 because we just want to do our initial processing in step 1 first. This is our initial extracting and fitting together. I'm not going to go through these in great detail, but there are some settings that we can look through for each one of these in terms of how high a resolution we process and what deliverables and things like that. But basically here we're just going to hit start, and we're going to watch it go through. And at this point, it's going through each image and it's extracting out key points. This is what we see, these little dots turn from red to green. And then when it has all the key points extracted from each image, this is where it's now going to go back and then try to match them together. So you see these little blue circles kind of flashing around through here. You can see on the bottom it's computing matches. And then once they're computed, they kind of turn this lighter seafoam kind of green color. And now the optimization is just going through and just kind of fitting things together, kind of refining and checking things. And then when it's done here, we will see our quality report pull up, where then we will see how well this all fit together. So it's just about done here. I can try to speed it up, but I'll probably go past it. Right here. So once it's done, we get our quality report. That pops up on the screen, and then it goes into our Ray Cloud view. So this is where we're looking at what we looked at on the slide earlier. What we can see, just making it a little bit bigger here, it looks like. What we can see first and foremost is our summary at the top. It kind of just gives us our project information, the area. This is where we see our statistics that we looked at earlier. We kind of get a preview of our surface model and our orthomosaic. This just kind of shows our images and maybe some of our matching errors, error ellipses. This just shows overlap information, block adjustment, ATP information. So a lot of camera stuff. And then here's kind of where we go down and we see our matches and our geolocation details. So I can scroll through this pretty fast, but a lot of the information here is very self-explanatory. What I do want to show is in here, if you're wondering what any of this information is, this report has all these little information icons here, and if you pick on those, it will pull up the help file and explain to you what all that information is. So we just kind of go through and we want to look at that and make sure everything looks okay. And there we are with step 1, our initial processing. Now the next thing we want to look at is adding manual tie points. So maybe if we look at our quality report and we have some areas that don't look so hot, maybe we need to add in some manual tie points. Again, this could be maybe more of a homogeneous surface where there isn't a lot of information. This one actually worked out pretty well, but just to show it, all I did here was I opened up, let me back up a little bit, is I opened up kind of your selection pane, which is this button on the right, and when you have that open, I just picked on any of these automatic tie points on the ray cloud view to pull up basically all the images on the right-hand side that contain that point. So if I hit the space bar in Pix4D, it pulls up whatever image I'm in full screen. So I'm just going to kind of look in that area and try to find something. You see there's a little white speck there, maybe not the best thing, but that's what I'm going to use here in the interest of time. And it's kind of in that dead area. So I'm going to hit this new tie point button, and it's going to name it manual tie point 6. I have some different options here, but I'm going to go back to my screen here, and I'm going to find my little white dot. And basically, I can zoom in or out, and I'm just going to put my cursor on there and pick there, set a point. And then I move to the next image. This one's kind of rotated 180 degrees, but I'm going to go find that same little white dot. I'm going to pick in that image. And now what I can do is if I hit this little center on button there, it'll center on that point on all the redundant images around it and kind of give me a preview of where it's putting that. So now I can kind of check and make sure everything is getting put in the right area. If some of them are off, I can go back and I can kind of move them. And I can also turn on my cameras and you can see the different rays from each image. So I can make sure that I've got enough images from all different directions, you know, kind of north, south, east, west, for lack of a better term, to kind of tie this together to make sure I've got good distribution between my images. When that all looks good, I can basically go back through and reprocess this using this manual tie point information, and I can tell it to basically use this and reprocess through it. So I'm just going to go down to my image here again, and this all for the most part looks pretty good. If I had any lighter spots, maybe kind of in that upper left-hand corner or down on the bottom, where I had spots where there was no matches, that's kind of the areas of my project that I'd be looking for to add these manual tie points in. And then up on the top, there's a re-optimize, and there's a rematch and re-optimize button. I'm not going to go into that, but basically that'll just kind of redo your adjustment, factoring in the manual tie points. The next one would be ground control points. So what this is basically going to do is it's a lot like the manual tie points, but I have my ground control point file brought in here, and you can kind of see on the screen that these little blue symbols kind of floating around in space here. You can see I have a little bit of a vertical issue. So I want to tie this down with my ground control points. So the process is going to be similar to the manual tie points, but I'm actually using like hard data here, as you can see in my GCP manager. There's two editors. There's a basic editor and a ray cloud editor. Personally, I think the ray cloud editor works a lot better, so I would recommend that you use that. But what we're going to do is we're going to open up our selection screen on the right, and then we're basically just going to pick one of our ground control points on the screen, and it's going to give us the same view that we saw with the manual tie point screen, where we can then go into the images and kind of start fixing things together to our targets here. So you can see I got nice big targets, nice and easy to see, and I'm just going to pick the center of the target, go to the second image, locate it, pick the center of the target again, and then again we can go back through and kind of recenter everything on those locations, and that makes it nice and easy for us to go through and pick these images in each, or pick the target, I should say, in each one of these images. So you can see some of them are off a little bit. We can go back through and we can refine them. I'm just going to go through just this one, and I'm going to skip through the others. But you can see I can go through and also pick the automatic matching. So based on my selections, you can tell it to automatically target your ground control. And it works pretty decent to an extent, but you can see kind of the circle that you get around your location. That's kind of like its estimated error, so it's a little bit bigger than just going through and picking, so you can zoom in and you can manually pick things to tighten that up a little bit. So I'm going to just skip forward here. You can kind of get the idea. I'm going to do all of my points here, and you can see here, if I back up, once we do them all, if I turn off there, you can kind of get this, we call it array here. So that's just kind of, this is where it's going to anchor the first one. So then now we move to the next one, and we basically repeat the process on all of them. You can see you kind of have all of our arrays here on how it's going to adjust them. If I back up here, sorry, I'm jumping around. But once I have them all kind of nailed down, I'm going to go up to the top and I'm going to choose re-optimize right here. So re-optimize means that, okay, I've got everything tied together, everything looks good, I've added ground control. It's just basically going to rewrite everything, but now it's going to use the ground control as part of it. You can see on the bottom it says optimizing with geo information. So it's going to go through and it's going to lock everything down to our ground control and readjust everything. And then the last thing we want to do is kind of go through, and the blue is our ground control and the green is basically our computed position. And we want to just check and make sure those things match up really well visually. So you want the little blue cone inside the green one is centered as much as possible and things like that. So it's just a visual check. And then once that's done, we can recreate our quality report, which we have here. And now we can see we've got a green check mark on the bottom here showing that we've added in ground control. And our mean RMS error is about 1/100th of a foot. So we're able to tie those together pretty tight with using the ground control. The other thing we notice up here, back up real quick, up here we notice our ground sample distance. Again, that pops up everywhere. It's about 1/2 inch. This is just our kind of our previews we're looking through. Again, going down, and then just at the bottom of the report there, it'll kind of give you your information on how well your ground control. At this point, we want to save the project because we've done kind of one of the more important steps is the initial processing and the ground control, so we definitely want to save that. And now we move on to step 2, which is creating our point cloud and our mesh. So once we've tied everything together with our ground control and everything looks good, we can go to step 2 down on the bottom. And notice that step 1 is done, it's green, which means it's completed. Step 2, we can set what kind of output we want, how dense we want our point cloud. Kind of tells you how fast it'll process and things like that. So there's some different parameters you can work with in here. Typically your output's going to be LAS, but you do have some different options there. Also, if you want to merge it into a single file, you don't want several LAS files tied together. If you want a 3D textured mesh, you can turn that on, and then again the resolution and the type of file you want it to create for you down on the bottom. And then when that looks good, we basically just close the window and hit the start button down on the bottom, making sure that step 1's not checked because we don't need to redo that, and just step 2 checked. And then we basically run through. I'm just going to speed it up here. It's going to again pull up our quality report, and then this is just going to kind of give you some statistics in your quality report as to how long it took to process, the resolution that you use, and the number of tiles and the number of points. So again, it's just some point cloud statistics. Again, that it just as you do step 2 and step 3, it basically just piles it onto the bottom of your report. And then here now you can see basically what we looked at before is we can go and look at our point cloud and our triangle mesh, which I'm going to skip because we looked at that already before we started. The last step is creating our surface model and our orthomosaic. So we have to create the point cloud first and extract that before we can create the surface model and orthomosaic. So with that said, we can basically go through and we can again set our resolution, the type of outputs and things like that we want to have, different types of formats. If we want a DTM or a DSM, we can output some additional things, but that's for maybe a later date. And we'll go through and process it again. It'll tell us our DSM, orthomosaic, and index results. So again, it'll basically just give us our statistics as to how long it took to process. Notice everything's processed in green. Everything looks good. If we open up our project directory here and we go into here, I have my project folder. You have your P4D file, which is like your project file, and then your folder. And you're going to have them basically the 3 steps each have a folder. So your initial is where you're going to get your report right there. And then if we go back to step 2, this is where we're going to be able to grab our 3D mesh, which is in this FBX and OBJ format. And then there's also a point cloud folder where we can go and grab our LAS file, which is basically our point cloud file right here. And then if we go to step 3, this is where we can grab our orthomosaic and our DSM. So we have our DSM TIFF image right there. And then if we go back to the mosaic folder, we have our mosaic image right there. So for looking in terms of where we get our deliverables to bring into, say, CAD or Trimble Business Center, something like that, we just grab them out of those project folders. All right, so that's the very super quick abridged version of Pix4D. Again, we're not diving into point cloud editing or volumes or mosaic editing, but again, this is just intended to be an introduction. It's very easy software to use. Does a lot of the work for you, takes a lot of the guesswork out of you, and gives you some very good results. So to kind of wrap this up here, I also want to just give a quick overview of Pix4D Cloud. Pix4D Cloud basically does the same thing that Pix4D Desktop does for us, but it does it kind of for you in the cloud. So what it is it's an online cloud processing service that you can upload your data files to. This service is included with your Pix4D license and your login. Basically, you just grab your images, upload them to Pix4D Cloud, tell it to process, and they'll notify you when the processing is complete. Once it's processed, you can download the individual deliverables, you can download the report, or you can even just download the whole project right from their little web interface that we see here. And then you can also share a link and collaborate with people online. So I just want to show you just kind of quickly what things look like in there. So I'm going to switch over to here. And this would be your Pix4D Cloud view. So you can see we have several projects here. You have your login. You can switch between Mapper. If you have a BIM license, you can switch to BIM, the ag or the model. These different licenses allow you kind of some different features here when you're logged in. You can upload a new data set. You have the downloads for the desktop and the mobile software as well. So here's our project here that we just looked at. I had it also processed through Pix4D Cloud. And it'll pull it up kind of in, this is basically like my orthomosaic here. And it'll pull it up kind of in a street view. And if we want, we can switch to a satellite view, and you can see that it all lines up pretty well with where we are in the real world. It just gives you some different things you can do here. It's pretty basic, but you can add in different types of annotations. You can do some different measurements of distance and area, kind of add in some markers or some comments. You have your orthomosaic and your base map. You can also load your DSM in here, and it kind of gives you some different parameters in terms of 310 meters, to 311 meters. You can also set kind of the density of it. So there's just some different visualization options in here, as well as going to the 3D view, which this little tab here pulls up. And once it loads here, we can switch it to maybe high def mode. It just makes it look a little bit better. But in here we can kind of spin around and again look at our 3D view of this this project that we processed. And again, we have some annotations and things like that. If we wanted to download the data, we just hit the download button and it says, okay, what do you want? So we can grab the whole project that we can load into Pix4D desktop. We can grab just the input images, orth mosaic, surface model, 3D mesh in either of these two formats, the point cloud, processing log, and the quality report. If we download the desktop or the project, we'll get all this information with it, but we can just grab our single deliverables there if we want. And then last thing I just want to show here quickly is we can hit the share button, and I can share a link to anybody here. And basically you can see that they will not get the original images or the output files. They'll basically just get the what we see in the web here, the visualization and the annotation. You can embed it with a link into a website, and you can upload it to Sketchfab also. So it's pretty basic, but it's pretty powerful. It's a good way if you just want to easily share your data with people and let them see it. And again, it's included with your login. So with that said, that's pretty much the end of it. Hopefully we didn't fly through too fast. I wanted to leave a little bit of time at the end for questions. So I guess at this time we'll go through some questions here and try to answer them. We have a few minutes left. Looking up here, there was a question about working with arbitrary coordinate systems with ground control. So yeah, you can definitely work in an arbitrary coordinate system. So if you have maybe like a local site, I know a lot of mines have arbitrary systems. The only, I won't say issue, but the only hurdle you have with arbitrary is that you won't be able to use kind of that 2D map view because it won't really know where to place things. And then in terms of your ground control, you might not have the ability to have it automatically pull up the images right away. You might have to add a couple in before it can kind of figure out where it's at, but it's definitely something that's possible that you can do. The next question is Pix4D Capture included with Mapper Pro? Pix4D Capture is just a free app, so even if you haven't purchased Pix4D, you can go ahead and download Pix4D Capture right now. It's in both the Google Play Store and the iOS iTunes Store, I think is what they call it. And if you don't have a Pix4D login, you can just create one, I believe, right in the app. If not, you can go online and just create one and use it that way. I think you can also use it without a login. The only difference is if you use it without a login, I believe you're restricted to maybe not being able to upload to the cloud directly from the app and a few other small things. There's a question for an 800-acre site, mostly ag. How many GCPs would you recommend? That's kind of hard to answer because, I mean, you could say throw one in each corner and one in the middle and call it good. I mean, it is a pretty large field. I would recommend some more. It depends if the terrain, you know, there's a lot of undulation. I would say definitely have at least 5, if not more. I would say a minimum 5, but it's really kind of hard to answer without seeing the site. Next question is, when the project is complete, someone asks what the accuracy was we look at to determine accuracy. So for example, if we say it's 3 centimeters, how do we find that in the quality report? The quality report is going to show you not only your overall accuracy relatively with the images, but it's also going to show your accuracy in terms of how well it tied to your ground control. And really your ground control is what's going to have the largest weight on anything that you do. Just for a kind of a quick kind of, well, this is about what it'll be kind of thing. Typically what we would see is you look at your ground sample distance, your GSD, and we would say, horizontally you're probably 1 to 3 times your ground sample distance, and vertically you're probably, I think it's 2 to 4 times your ground sample distance, and that's obviously in a very good controlled environment, but that would at least give you kind of a rough idea. So the question was, can you show how to do a local grid system match arbitrary system? I don't have a project I can pull up and necessarily do that, but what I can show you is when you do a new project and you set up your coordinate system, your output system, in there is an option to pick arbitrary. Again, when you bring in your ground control, there's also an option to set arbitrary. It may be hard to do here because I don't have images. And won't let me go to the next one, but when it asks for your output system, there is a selection there for arbitrary, which is what you're going to be choosing. Trying to get going here. Where are we? We are here. So have you seen or developed a PRJ file for Minnesota, Wisconsin County Coordinate System? That's a very good question, Eric. That is a bit of a hurdle, obviously, working in Minnesota. What I've been doing is if you can go, there is a website, you can go and grab some of that stuff, and if it's in there, you can bring it in. It does work. I've also seen some PRJ files where I brought them in and it doesn't work, so it kind of depends on the source that you get them from. I've been successful in a few projects where I've brought data into Trimble Business Center and exported out a shapefile, which will export out a PRJ file. That's worked in some cases, but in some it hasn't. It kind of depends on various things, but yeah, it can certainly be done. Next question, how much can you store in the cloud? I would have to look into that. I'm not sure what the limits are and what they kind of relegate you to. I'm not 100% sure. Let's see, so there's some questions on cameras between a Inspire 1 with the stock camera and a Phantom 4 Pro, which would be better. I don't know for sure what kind of camera the Inspire 1 has. I would look at probably the type of sensors they have. I am pretty impressed with that Phantom 4 Pro camera, which also has a global shutter instead of a rolling shutter, so that's another advantage. I would tend to lean towards that, but I would have to look at the specs to make sure. Ground control targets, where do we get them? We had them printed somewhere in Colorado. It kind of just depends on what you need. I think the ones that we have are kind of like those vinyl banners you would see hanging on like bingo halls and liquor stores and stuff. It's just kind of that vinyl material we had printed. They work pretty well, but sometimes if it's real light, they can get a little shiny. So I've seen people use lids of 5-gallon pails. I've seen people make them out of cardboard. You can kind of get them anywhere. GCPs for cloud processing, that's a good question. There is no uploader for GCPs for cloud processing. What I would recommend there is you could have it cloud processed, but if you wanted to tie to GCPs, you probably need to download the Pix4D project and then add them in and just kind of recompute everything. That seems to be the method that I've found. Also, kind of related to that, methods used for tying your GCPs. This kind of gets into the surveying realm, but should you use a static or an RTK or conventional instrument? It depends on the project and how accurate you need your GCPs to be. I mean, if you're looking for extreme accuracy out of your ground control, I mean, you could, if you want to do a full-on static network and tie to, base station and post-process, you can definitely do that. But typically, with the type of accuracies you're going to get out of photogrammetry from a UAS platform, you're probably just fine using RTK, to be honest with you. Just trying to monitor. We got a few minutes left here. I got a few more I'm looking at. So I got a comment here. It says I work at a mine. Or hold on here. Elevations. No piles match your GPS quite well over the top of the piles elevation of 3 feet. So there's a question about doing piles and some issues where the tops of the piles are off. So a couple things you can do. One thing I didn't show in Pix4D is you can bring in multiple flights. So what I mean by that is you could do, if you have a pile situation, you could first do like a nadir or an oblique flight over an area where you may have stockpiles. You can also then do maybe a 3D, like a circular type flight, which is going to be better for a 3D model. So you could do a nadir flight, you could even do an oblique flight, but you can also pitch the camera at, say, 50 degrees and just fly around the center point in a circle and take pictures. That might be one way if you're having some vertical issues to try to tie things together a little bit tighter. You can certainly integrate multiple flights into a single project. That's the first thing I would look at. Otherwise, you could try throwing a ground control target at the top of the pile. Obviously, if you're flying the pile because you can't crawl on it, that's an issue. Then I'd maybe try a different type of flight. Recommendation for size of GCPs, I'm guessing that's the target. I would just say something that's big enough that you can see, the highest you can fly is 400 feet, so if it's something you can see from 400 feet, it's probably just fine. Can you target specific points to get an elevation on, say, a manhole top of curve? I'm guessing this is maybe after it's processed. In the point cloud, definitely, because each one of those points is going to have a 3D position on it. Maybe, tops of manhole covers and things are where it would be nice to have some checkpoints, just to have some of those hard surfaces that you can check and reproduce. But in terms of the deliverables, yeah, everything in the point cloud has a 3D coordinate. Yeah, so here's a good question. It says, if I set my flight height at 100 feet and the ground is at a slope, does my UAV fly 100 feet parallel to the ground? No, it does not. So typically, with the experience that I've seen with all these UAV platforms, your flight height is based off of your starting point. So wherever your UAV was when you do your pre-flight and your setup and you take off from, it's going to fly 100 feet above that. So if it's going uphill, as you go uphill, it's going to be less. If it's going downhill, it's going to be more. So you might want to look into staggering several flights at different levels to try to account for that. So here's another good question. Example you use are bare earth. What happens in flying over egg fields of crop growth to the data can process bare earth. So one thing to keep in mind is if you're looking from a simple camera RGB perspective, all it is pictures, right? So if you have vegetation, say like a cornfield or something like that, typically you're going to get the top of the corn or the top of the sugar beets or whatever it is because there's no technology there to penetrate through that. That comes up a lot if you're trying to use UAS for purpose of maybe penetrating wheat or crops and get bare earth. That's where we're probably more looking into a LiDAR type survey, something that it's actually producing or shooting out a point cloud versus creating one from images, because that's going to be definitely a drawback of using just pictures. There's going to be vegetation. Let's see, a couple more questions and then we're probably going to wrap it up here, it looks like. It says, what kind of accuracies are you pulling out of the data under 1/10 of a foot or above? I understand that can change depending on what method is used to collect GCP data. Again, a lot of that's going to depend on your ground sample distance. I've seen some where we've flown really, really low and we've had a really high resolution camera, really good ground control. We've hit within, I don't know if I've ever hit below 1/10 of a foot, maybe in a few spots here or there, but certainly not consistently across the project. There's a lot of variables in terms of how it fits together. I usually say a couple of tenths we can do relatively easy. Don't be fooled by when you hear things that say it's survey grade accuracy where you're expecting to get a centimeter, absolute accuracy. I don't see it. Maybe some instances you can. We can get pretty close, but sometimes it's just better to pull out the total station or the GPS. And then the next question, or the last question I have here is one I don't know if I can answer, but it's how easy can I import my data into MicroStation? That all just depends on how well MicroStation handles LAS files or some of the other outputs. Like I said, I think there's 5 or 6 different control point cloud outputs. So more of it is just knowing what MicroStation needs and what they will import, and also with the images as well. From what I understand, our MicroStation can handle it pretty well, but I can't speak specifics because I don't have MicroStation. All right, so I think we hit our whole question list, actually. That's pretty good, and I think we're pretty good right on time, too. Steve, is there anything I'm missing that you're seeing on your end, or?
Nope, those were all the questions that I saw.
Okay.
And we are right up against the clock of our time, so with that, I think we're going to end today's webinar. Again, remind everybody that there will be a recording of this available here by the end of the week. We typically broadcast it over our blog sites. Jay alluded to what those were, fpimapping.com or fpisurveying.com. If you're not on the blog, just certainly go to one of those two sites and register, and you'll receive the playback information so that you can go back and share it or review it and have it available to those around you that you may want to reference, or again just play back to get more information. I do want to thank everybody for taking the time today. I know it's the middle of the summer, things are busy. Appreciate that, and with that we're going to go ahead and sign off. Thank you very much. Have a great rest of your day.
Yep. Thank you, everybody. Appreciate it.